Most organizations believe they are AI ready because they have Microsoft 365 licenses and a Copilot pilot underway. They are wrong. The real question is not whether you have Copilot, it is whether your tenant can handle what Copilot will do. AI does not fail because the model is weak. It fails because organizational infrastructure is unprepared. You do not need better AI. You need a functioning knowledge architecture. You do not need more licenses. You need governance that actually works. This episode examines 5 pillars of AI maturity through the lens of enterprise architecture. We will use real tenant diagnostics to reveal why 80% of AI pilots never reach production. The uncomfortable truth: you are probably not ready, and the cost of finding out after deployment is substantial. The foundation problem: why ready is a mirage. Organizations conflate licensing with maturity. They see Copilot on the feature list, budget the per-seat cost, and declare themselves ready. This is not readiness. This is liability with a purchase order attached. The AI tax is real. Starting July 2026, Microsoft is bundling Copilot into M365, E3, and E5 plans, imposing a 15 to 25% cost increase on typical enterprise agreements. For a $10 million EA, that is $2.5 million annually, yet only 39% of organizations report measurable impact from AI investments. You are paying the tax regardless, but cost is not the real problem. The real problem is governance. 82% of IT leaders report severe operational burdens managing M365 environments. Nearly 50% experienced misconfigurations causing security or compliance issues in the past year. 53% say AI initiatives are outpacing governance maturity. These numbers do not describe technical gaps. They describe organizational chaos masquerading as infrastructure. Shadow AI is the hidden cost structure. 63% of organizations lack any AI governance initiative. When governance is absent, employees deploy agents, integrate APIs, and build workflows outside formal processes. These shadow systems inherit broad permissions by default. They access data they were never intended to reach. When a breach occurs, and it will occur, the cost averages $670,000 higher than it would have been in a governed environment. Most enterprises operate in a state of managed chaos where AI simply accelerates existing problems. You do not fix this by buying better tools. You fix it by building governance that actually constrains what can happen. Consider the architectural debt accumulation pattern. During awareness and pilot stages, what most organizations call maturity, departments run isolated experiments. These create technical debt. Teams build one-off integrations without enterprise architecture oversight. They duplicate data connections. They establish incompatible endpoints. By stage 3, when you try to operationalize AI, this debt becomes irreversible. You cannot unify what was built to be fragmented. Most Copilot deployments stall between week 6 and 12. This is not coincidence. It is when governance finally matters. The leadership says we are ready. IT says we need to understand data access. Security says we need DLP policies. Compliance says we need audit trails. The deployment halts while these conversations happen. Organizations confuse the initial enthusiasm with operational readiness. The foundation problem is this: you have spent the last decade building collaboration environments without governance discipline. SharePoint sprawls across hundreds of sites with inconsistent governance. Teams channels operate with open sharing norms. Overshared content reaches 83% of at-risk files internally and 17% reach external parties. Sensitivity labeling covers less than 20% of critical data. This is your actual knowledge architecture. Copilot will see all of it. When you deploy Copilot into this environment, the AI operates on the Microsoft graph, the underlying permission structure and knowledge network of your organization. If that graph is unhealthy, Copilot will expose that dysfunction. An employee with access to sensitive engineering data through 3 levels of permission inheritance will suddenly be able to ask Copilot to retrieve it in seconds, not because Copilot is dangerous, because your permission structure never accounted for AI-driven discovery patterns. The mirage is this: organizations see their licensing investments, their Azure spending, their Microsoft 365 adoption rates, and believe these equal readiness. They do not. They are table stakes. Readiness is determined by whether you can answer this question: what data can Copilot access, and is that what we intended? Most organizations cannot answer that question. This is the maturity trap. You believe you are at stage 3, operationalized and ready, when you are actually at stage 2, running isolated pilots with no centralized governance. The gap between perceived maturity and actual maturity is where deployment risk lives. The 5 pillars framework. A diagnostic tool. Microsoft's AI maturity framework defines 5 stages of organizational AI adoption. Most organizations misunderstand what each stage actually demands. This is not a marketing framework. This is a diagnostic tool for understanding where you actually are, not where you think you are. Stage 1 is awareness and foundation. This is where organizations buy licenses, attend briefings, and declare AI as a strategic priority. Leadership sees AI as inevitable, not strategic. The question at this stage is simple: do we understand what AI could do for us? You do not need advanced skills here. You need buy-in and a willingness to experiment. Stage 2 is active pilots and skill building. Departments run isolated experiments. A team in finance tries Copilot for reporting. A group in marketing experiments with content generation. A division in operations tests agent automation. These pilots often succeed. They produce visible wins. But they are isolated successes that do not replicate. They create technical debt. They establish incompatible data integrations. They consume budget without establishing organizational standards. At this stage, you have pockets of proven value scattered across departments. You do not have a platform. Stage 3 is operationalize and govern. This is where most organizations fail. At this stage, you must build infrastructure. You need an AI center of excellence with cross-functional governance. You need data platforms that can serve multiple use cases. You need consistent security models and compliance frameworks. You need to retire the isolated pilots and consolidate what worked into enterprise systems. You need to establish standards for how agents are built, how data is accessed, how risks are managed. This stage demands sustained investment in governance, not just technology. Most organizations attempt it without understanding the effort required. Stage 4 is enterprise-wide adoption and scaling. At this stage, Copilot and custom agents are integrated into core workflows across the organization. Knowledge workers use AI routinely. Agents handle routine tasks. Data flows reliably into AI systems. This only becomes possible if stages 1 through 3 were executed with discipline. Stage 5 is transformational AI. This is where agentic AI, autonomous agents that execute workflows with minimal human oversight, becomes viable. Agents handle supply chain disruptions. Agents monitor compliance. Agents execute financial processes. This is only possible if every stage before it is flawless. One governance gap scales into catastrophic risk at this level. The trap is this. Most organizations believe they are at stage 3. They are actually at stage 2. The illusion emerges from successful pilots. Finance says the reporting agent is working well. Operations says the process automation is saving hours. Executive sponsor declares victory. The organization assumes this means they are operationalized. They are not. They are still in isolated pilots. They have created visibility into what works in controlled circumstances. They have not built the infrastructure to scale those successes across the enterprise. The cost of this misperception is enormous. Organizations deploy Copilot enterprise-wide at stage 2 maturity. They expect the productivity gains they saw in pilots. They encounter governance gaps, data quality problems, permission misalignment, and security concerns. The deployment stalls. They decide Copilot is not ready for their organization. What actually happened is their organization was not ready for Copilot. Understanding where you truly are requires looking past what leadership believes and examining how the tenant actually operates. This is what diagnostic signals reveal. Not what executives declared, not what pilot results promised, but what the data in your Microsoft graph actually shows about knowledge distribution, governance maturity, and whether Copilot can operate safely in your environment. This is not a theoretical exercise. Your actual maturity determines whether AI succeeds or becomes another expensive tool that gets shelved when the pilot ends. The Global Manufacturing Enterprise Case Study, Data Chaos Under the Surface. Consider a global manufacturing enterprise, 50,000 employees, structured ERP systems, significant Azure investments. The organization manufactures industrial components across 12 countries. They have invested heavily in Microsoft 365. They run Copilot pilots in supply chain planning, manufacturing optimization, and financial forecasting. Leadership is confident. They have data. They have infrastructure. They believe they are ready for AI. The leadership narrative is this. We run disciplined operations. We have enterprise systems. We have governance frameworks. We are obviously prepared for AI. The reality is different. SharePoint sprawls across hundreds of sites with inconsistent governance. Some sites follow naming conventions. Most do not. Ownership is unclear on 60% of them. Permission inheritance is broken in ways nobody has mapped. Teams' channels operate with open sharing norms. Channels are created daily. Access is broad. Overshared content reaches 83% of at-risk files. Most employees can access information they have no legitimate reason to reach. Sensitivity labeling coverage is below 20%. Critical engineering documents, designs, specifications, supplier contracts lack any classification. Supplier agreements are sometimes in email, sometimes in shared folders, sometimes in OneNote notebooks. The organization has no unified knowledge architecture. It has evolved chaos. The organization has invested in governance tools. Purview exists in the tenant. DLP policies are defined. They are simply not comprehensive enough. They do not cover the knowledge chaos. They do not reflect how engineers actually work. They do not account for the dozens of informal collaboration channels where critical information lives. When Copilot is deployed, it operates on the Microsoft graph. It has access to everything the user can access. An engineer in the US plant can ask Copilot to summarize supplier contract terms. Copilot retrieves documents from shared drives. It retrieves emails from searches. It retrieves OneNote notebooks. It synthesizes information the engineer never explicitly opened and aggregates it in seconds. The information was already accessible through permissions. Copilot made that accessibility instant and invisible. Here is the critical risk. An employee, whether malicious or careless, can suddenly retrieve information they technically have access to, but were never intended to use. An engineer can ask Copilot about supplier margins across all contracts. A planner can retrieve competitor intelligence accidentally stored in collaborative folders. A manager can synthesize personnel information from email that was never meant to be aggregated. The organization has not experienced a breach, but the breach surface has expanded dramatically, and the exposure is not coming from Copilot's weakness. It is coming from permission structures that were never designed for AI-driven discovery at machine speed. The smoking gun appears within weeks. After Copilot deployment, DLP events spike 300%. The organization suddenly sees what was hidden, egregious oversharing patterns that existed all along but were invisible under human-scale access patterns. A document marked confidential shows up in a channel accessible to thousands. A supplier contract sits in a shared folder that was created 3 years ago and nobody remembers why it is open. Engineering specifications are accessible by the entire manufacturing division, not just the teams that need them. The organization did not create this problem through AI. AI made the problem visible. And when visibility arrives, the question becomes urgent. How did this happen? How are we managing critical information this poorly? The answer is simple. They were not managing it. They had evolved patterns that worked for human-scale collaboration. AI operates at a different scale. The DLP spike forces action. The organization must either remediate the oversharing or constrain Copilot's access. Both options are expensive. Remediation means months of permission audits, document reclassification, and workflow redesign. Constraining Copilot means limiting its value. Either way, the deployment stalls. This is where the manufacturing enterprise actually is. Stage 2 maturity with a Stage 4 deployment. Isolated pilots revealed benefits. Enterprise rollout revealed that the underlying infrastructure cannot sustain AI-driven knowledge work safely. The pattern is not unique to manufacturing. It repeats across industries, but the risks differ. The financial services organization case study, governance becomes a prison. Now consider the opposite problem. A financial services organization with 10,000 to 20,000 employees operates under strict compliance frameworks, banking regulations, audit requirements, customer privacy obligations. The organization has invested heavily in governance. Data classification is rigorous. Access controls are enforced. Policies are documented. Leadership is confident for different reasons. They have built governance that rivals most regulated enterprises. They assume this means they are AI ready. The leadership narrative is this: we have strict governance, we have compliance discipline, we are obviously prepared for AI. The reality is inverted. Data is over-restricted and fragmented across compliance silos. Each regulatory domain maintains separate systems. Lending has one data structure, trading has another, compliance has its own repositories, risk management operates independently. These silos were created intentionally to enforce separation of duties and prevent conflicts of interest. The silos work, they achieve their compliance objectives perfectly, but they also prevent knowledge synthesis. An executive cannot ask Copilot to analyze lending patterns alongside market risk without triggering access violations. A decision maker cannot retrieve customer information alongside product usage because those data sources are intentionally isolated. Knowledge that is critical to decision making is buried in individual inboxes or locked behind approval workflows. Employees have adapted. They bypass formal systems constantly. A trader emails spreadsheets instead of accessing the formal risk repository. An analyst maintains a personal database of historical patterns instead of querying the governed system. A manager copies information to OneNote instead of using the approved analytics tool. The organization has inadvertently created shadow workflows that circumvent governance. The intended control structure now works against productivity. The organization has built perfect governance with zero organizational value. Compliance is flawless, data is protected, audit trails are immaculate, and the organization is operating less efficiently than a smaller firm with looser controls because employees waste time working around the governance structure instead of within it. When Copilot is deployed, the problem becomes stark. Copilot can only access data the user is entitled to see. In this organization, that entitlement is tightly scoped. An executive who needs broad perspective across the organization can only access information their role explicitly permits. An analyst cannot cross silos to synthesize patterns. Copilot has access to less than 40% of the knowledge it needs to generate useful insights. In the manufacturing enterprise, the problem was Copilot accessing too much. In the financial services organization, the problem is Copilot accessing too little. The governance is not wrong. The governance is perfect for what it was designed to do. But what it was designed to do was enforce separation and prevent knowledge synthesis. That objective is incompatible with AI-driven productivity. AI thrives on data integration and pattern synthesis. Governance designed to prevent both will strangle AI. The organization faces a choice. Relax the controls and accept compliance risk. Maintain the controls and accept that Copilot will produce mediocre results. Both options are unacceptable. The first violates regulatory frameworks. The second makes the AI investment pointless. The file co-authoring activity tells the story. Across the organization, collaboration happens outside Microsoft 365. Shared documents live in email attachments. Real-time collaboration happens through email chains and phone calls, not through loop components or teams. The knowledge architecture is intentionally fragmented. Copilot operates on an information landscape that was deliberately designed to prevent the kind of knowledge synthesis AI requires. The DLP events do not spike, the security team is satisfied, the audit is clean, and the organization has an expensive AI tool that cannot function effectively in the environment where it was deployed. This is where the financial services organization actually is, stage 1 or 2 maturity with a stage 3 governance framework. The governance is mature. The organization's ability to leverage AI is not. The controls work perfectly. The productivity gains never materialize. The uncomfortable truth. Perfect governance at one maturity stage becomes a prison at another. The organization built governance to prevent risk. Now it must rebuild governance to enable innovation. That transformation is not a configuration change. It is architectural. The healthcare provider network case study, scale without structure. Now consider a healthcare provider network, 5,000 to 15,000 employees across multiple hospital systems, clinics, and research facilities. The organization manages massive data volumes, patient records, clinical observations, imaging data, laboratory results, pharmaceutical research. The organization operates under strict compliance frameworks, HIPAA, state medical board regulations, accreditation standards. Leadership looks at the data volume and makes an assumption common in healthcare. We have more data than anyone. AI will generate insights. We are ready. The leadership narrative is this: scale equals readiness. Data equals capability. We are obviously prepared for AI. The reality is fragmentation. Data lives in multiple systems that were never designed to communicate. The electronic health record system stores clinical data. The billing system stores financial data. The pharmacy system stores medication data. The imaging system stores radiology data. Administrative systems store operational data. These systems do not integrate. They were built at different times by different vendors to solve different problems. Patient data exists in all of them, but the patient identifier differs. The data governance model differs. The access control differs. The compliance framework differs. Microsoft 365 collaboration exists on top of this fragmented landscape. Clinicians use Teams to coordinate care. Administrators use SharePoint for operational procedures. Researchers use OneDrive to store datasets. Email carries clinical information that was never meant to persist outside the EHR. The Microsoft 365 environment has become a secondary repository for healthcare data that should live nowhere except the governed clinical systems. Sensitivity labeling is inconsistent across departments. Some departments classify patient information, most do not. Some mark research data as sensitive, others treat it as internal collaboration content. There is no unified standard. A clinician in one hospital might classify a treatment plan as protected health information. A clinician in another facility might treat the same information as internal notes. The organization has no governance framework that enforces consistent classification across the Microsoft 365 environment. Permission inheritance is broken in ways that create compliance exposure. A researcher who needed access to a dataset 5 years ago still has read permissions to folders containing current patient information. A contractor who worked on a project 2 years ago maintains access to team sites. Access reviews happen annually if they happen at all. The organization accumulates permission debt the way it accumulates clinical debt through inattention and the pressure of immediate priorities. When Copilot is deployed, the problem becomes regulatory. Patient data exists in Teams channels with inconsistent classification. Copilot inherits user permissions and can retrieve patient information from collaboration spaces that were never designed to be primary data repositories. An employee with broad access, a nurse practitioner, an administrator, a researcher can ask Copilot to retrieve patient information across multiple hospital systems. The system can synthesize patterns from data that was never intended to be integrated. The organization has not violated HIPAA through negligence. The organization has created an architecture where HIPAA violation becomes possible through routine use of collaborative tools. Copilot is not the culprit. Copilot is the mechanism that makes the existing risk visible and actionable. Insider risk alerts spike post-Copilot deployment. The organization suddenly detects unintended access patterns. An employee retrieved patient data outside their normal scope. A user queried research datasets they had permissions for but no clinical reason to access. A contractor still has access to information they should have lost years ago. None of these patterns are new. They existed all along. Copilot made them visible because Copilot accelerates access patterns that humans would never intentionally execute. The regulatory bodies pause approvals. State medical boards want assurance that patient data governance is proven before AI systems are allowed to operate in clinical settings. The organization cannot provide that assurance. They do not have unified governance. They do not have consistent classification. They do not have access controls that reflect actual clinical need. The governance framework exists for financial and billing systems. It does not exist for Microsoft 365 collaboration spaces where healthcare workers increasingly document care. The cost is delayed innovation. Healthcare organizations that can demonstrate mature governance deploy AI faster and more broadly. They gain competitive advantage in care quality, operational efficiency, and research capability. This organization becomes a laggard not because Copilot failed, because their information architecture cannot support AI safely until governance is rebuilt across silos and unified across systems. The pattern emerging from these three case studies is this: no organization is ready for AI. Not because AI is dangerous, because AI exposes the fact that information governance was never architected to support machine-speed knowledge synthesis. Every organization that deploys Copilot without fixing that architectural gap will encounter the same stall at weeks 6 through 12. The question is not whether you have data. The question is whether you have governed it. The fast-growing tech scale-up case study, velocity without boundaries. Now consider the opposite extreme, a fast-growing technology scale-up. 1,000 to 3,000 employees, founded within the last decade, digital native from inception. The organization has never used on-premises infrastructure. Everything is cloud, everything is collaborative. Speed is a cultural value. The motto is something close to move fast and break things. Leadership looks at their culture and makes a confident assumption. We are agile. AI adoption will be effortless. We were built for this. The leadership narrative is this: we are young, we are digital native, we do not have legacy constraints. AI adoption will align perfectly with our culture. We are obviously prepared. The reality is chaos with velocity. The organization has built an extremely open sharing culture by design. Sharing links are the default. A document is created in SharePoint. It is immediately shared with a link. No complicated permission structures, no approval workflows, no governance layers, just share, collaborate, move forward. This culture worked brilliantly for the first 5 years. It enabled speed, it reduced friction, it prevented the bureaucracy that kills startups. But it also created an information landscape with no boundaries. Anonymous sharing links are normalized. External sharing is the default collaboration mode. Partners get access, customers get access, contractors get access. The organization has no unified approach to data classification. There is no retention policy. There is no lifecycle management. Documents are created, shared, and forgotten. They accumulate. The team's environment expands faster than anyone can track. New channels spawn daily. Access is perpetually broad. The organization has never experienced a breach. From the outside, everything looks fine. They are growing. They are shipping product. They are raising capital. The board is satisfied. The investors are happy, and the information architecture is a ticking liability. 17% of at-risk files are shared with external parties. Not through malice, through velocity. A product manager shares a roadmap with a partner. An engineer shares architecture diagrams with a contractor. A sales team member shares customer lists with an agency. None of these sharing decisions are made maliciously. They are made in service of moving fast, but they accumulate into intellectual property exposure. Competitive intelligence lives in shared drives accessible to external parties. Product strategy is visible to contractors working on adjacent projects. Customer data is spread across external collaboration spaces. The organization has never classified data as sensitive. There is no governance framework for data categorization. Everything is effectively internal until it is deliberately shared externally. And since sharing is the cultural default, much that should be internal gets shared. When Copilot is deployed, the problem becomes regulatory. Compliance reviews begin. The organization discovers that they cannot demonstrate data governance. They have no way to prove that customer information is protected. They cannot show that intellectual property is classified appropriately. They cannot explain why external parties have access to internal collaboration spaces. They have no retention policies. They have no audit trails for sensitive information. The security team escalates. They demand controls. They want to restrict Copilot's access to classified information. But the organization has classified almost nothing. They want approval workflows for external sharing. But external sharing is how the organization operates. They want retention policies, but the organization has never had document lifecycle management. The security demands feel like governance theater. They feel like bureaucracy imposed by outsiders who do not understand startup culture. The conflict becomes cultural. The organization builds speed through open collaboration. They are now being told that speed requires governance. The cultural cost is enormous. Moving fast and breaking things must become moving carefully and governing more. Executive alignment shatters. The product leadership wants to maintain velocity. The security leadership demands control. Finance wants to prove compliance. HR wants to protect the culture. There is no consensus on how much governance is necessary versus how much is excessive. Copilot deployment stalls not because the technology failed, because the organization cannot reconcile its cultural values with the governance infrastructure AI requires. This is the maturity trap for scale-ups. Velocity was the competitive advantage. Governance feels like the thing that kills velocity. Until they realize governance is the thing that enables scale, by then the cultural change required is profound. The organization faces a choice that larger legacy companies made decades ago. Culture shifts or competitive advantage disappears. That transition is not painless. The public sector organization case study, governance without agility. Now consider a public sector organization, 5,000 to 10,000 employees across multiple agencies or departments. The organization operates under stringent compliance frameworks, budget constraints, procurement regulations, security clearance requirements, oversight by elected officials and audit agencies. The organization has invested in governance infrastructure over decades. Controls are documented, compliance is audited. Leadership is confident for straightforward reasons. We have governance, we have security clearances, we have compliance frameworks. We are obviously ready for AI. The leadership narrative is this: we built governance to survive scrutiny. We are prepared for anything. We are obviously ready for AI. The reality is stagnation. The governance infrastructure exists. It is also entirely built for a document management world that ended 15 years ago. Permission structures are complex and outdated. A document stored on a file share has access controlled by folder permissions. Those permissions were assigned when the document was created. Nobody has reviewed them since. Entitlements accumulate and are never revoked. Access reviews happen annually if they happen at all. The organization has governance without maintenance. Collaboration adoption is low. Teams is deployed but used sparingly. Most knowledge is stored in file shares, not modern collaboration platforms. Email carries organizational knowledge that should live in shared systems. Institutional memory is distributed across individual inboxes. A person who leaves takes years of email-based knowledge with them. The organization cannot retrieve what was never captured in a unified system. Document metadata is inconsistent. A file is created in a folder. The folder has a naming convention that was established in 2009. The document itself has no metadata that describes its content, classification, or purpose beyond what the folder structure implies. Search is poor. If you do not know the approximate location of a document, finding it is nearly impossible. An employee asks a colleague, "Where is the budget template?" The colleague remembers it is somewhere in shared drives, finance folder, maybe in planning or maybe in forecasting. The employee manually navigates through folders. Eventually they find it. This is how the organization locates critical information. When Copilot is deployed, it encounters an information landscape designed for human-scale navigation at folder level, not machine-scale retrieval. Document metadata is sparse. Copilot cannot understand what a document contains beyond the file name. There are no labels. There is no classification. There is no semantic structure that allows AI to infer relationships between documents. A budget template sits in a folder alongside budget forecasts and budget analyses. Humans understand the distinction because they have institutional knowledge. Copilot cannot. The system lacks the semantic structure that allows machine learning to function. The collaboration signal tells the story. Teams adoption is 40% lower than comparable private sector organizations. Employees have not migrated knowledge to modern platforms because the governance framework was built for file shares. Migration requires recapturing permissions. It requires documenting access rules. It requires updating metadata. The effort is substantial. Budgets are constrained, so the knowledge stays where it is. The knowledge signal is more telling. File co-authoring activity is minimal. Documents are versioned through email. An analyst completes a report. She emails it to her manager. The manager edits it offline and emails it back. The analyst incorporates changes and emails the updated version to stakeholders. 14 email exchanges later, the document is finalized. The final version is stored in a file share. Nobody can find it 3 months later because the naming convention changed. But in the moment, it worked. Email is the de facto collaboration platform because it works within the existing governance structure. The governance cost is paradoxical. Regulatory compliance is flawless. The organization passes every audit. Data is protected. Systems are secure. And organizational agility is sacrificed on the altar of compliance. The very governance that ensures regulatory safety prevents the knowledge synthesis that modern work requires. The cost of change is transformational. Moving to modern collaboration requires cultural and process transformation. It requires retraining how work gets done. It requires rebuilding permission structures. It requires maintaining 2 systems during transition. The initial cost is enormous. The political cost is also enormous. A legislator or oversight body might ask, why are you changing how you manage documents? The current system passes audit. The change introduces risk. Why take that risk? The organization faces the same choice the financial services organization faced: maintain governance and sacrifice agility, or modernize collaboration and accept that change introduces temporary risk. Either way, Copilot cannot operate effectively in a knowledge architecture that was never designed for AI. These 5 case studies reveal an emerging pattern. Maturity is not about what you own. It is about how you operate. The diagnostic signals: reading the health of your tenant. The 5 organizations just described have one thing in common: they cannot diagnose their actual maturity. Leadership makes declarations. Executives present confident assessments. None of these declarations are useful. What matters is what the tenant actually reveals about how work gets done. True maturity reveals itself through behavioral signals, not what leadership believes. These signals live inside the Microsoft 365 environment. They are measurable, they are objective, they do not require consultant interviews or subjective interpretation. They answer a single question: can this organization's knowledge architecture support AI-driven discovery safely and effectively? Collaboration signals show how knowledge is actually distributed across the organization. Anonymous sharing links are a signal. When sharing links are the default, the organization has deprioritized access control. Governance exists but is not enforced operationally. External sharing patterns tell another story. What percentage of at-risk files are accessible to people outside the organization? 17% is a scale-up problem. 0% is a financial services problem. Teams channel sprawl reveals whether the organization is managing growth or being overwhelmed by it. If channels are created without lifecycle management, if ownership is unclear, if access is perpetually broad, the organization is operating in reactive mode. The knowledge landscape is expanding faster than governance can keep pace. These signals alone do not determine readiness, but together they show whether the organization has made governance a continuous operational discipline or treated it as a compliance checkbox. Governance signals measure whether data governance frameworks actually function. Sensitivity label coverage is the most direct signal. What percentage of critical data is classified? 20% means classification is aspirational. 50% means there is a governance discipline but inconsistent adoption. 80% means governance is embedded in workflows. Below 50%, Copilot will operate in an environment where most data lacks classification context. That is, architectural liability. Retention policy adoption shows whether the organization has lifecycle management. If retention policies are absent or apply to less than 50% of repositories, the organization accumulates data without discipline. Documents persist beyond their usefulness. All permissions remain active. Access continues beyond necessity. DLP event patterns after Copilot deployment reveal how many governance violations were hidden before AI made them visible. A 300% spike means the organization had catastrophic oversharing that remained invisible under human-scale access patterns. Knowledge signals reveal whether knowledge is captured in unified systems or scattered across individual inboxes. The ratio of SharePoint knowledge versus email knowledge is telling. If most institutional knowledge lives in email, the organization has failed to establish collaborative platforms as the primary knowledge repository. Employees are not capturing information in ways that allow synthesis or retrieval. Document metadata quality determines whether AI can understand what a document contains beyond its file name. If metadata is sparse, if descriptions are minimal, if classification tags are absent, Copilot will struggle to understand document relationships and context. Loop adoption shows whether the organization has moved beyond document storage to collaborative work. Teams with active Loop components are conducting work in modern platforms. Teams without Loop are using Teams as a messaging tool and storing actual work elsewhere. Security signals determine whether Copilot will expose unintended data relationships. Permission complexity is a liability. If the organization requires 3 levels of permission inheritance to understand who can access what, governance has become operationally impossible. Guest user access patterns reveal whether external access is governed or has sprawled. Privileged access usage shows whether the organization is implementing least privilege principles or whether elevated permissions are perpetually held. Microsoft Graph signals are the most critical because Copilot operates on the graph. File co-authoring activity shows whether knowledge work is happening in shared documents or in isolated versions exchanged through email. Cross-team collaboration patterns reveal whether the organization is breaking down silos or reinforcing them. Meeting document integration shows whether decisions are recorded in accessible systems or captured only in email summaries. The critical insight is this: Copilot operates on the Microsoft Graph. If your graph is unhealthy, Copilot will expose that dysfunction. Oversharing becomes visible. Ungoverned data becomes accessible. Scattered knowledge becomes synthesizable. The AI does not create these problems. It makes them impossible to ignore. The readiness question reduces to this: can your organization answer what data Copilot can access? If you cannot answer that question with certainty, you are not ready. Full stop. No amount of licensing changes that answer. No amount of pilot success proves otherwise. You do not have a maturity problem. You have a visibility problem. And visibility is the prerequisite for everything that follows. The AI Readiness Scorecard, Self-Assessment Framework. Understanding where you actually are requires a systematic assessment. Not a consultant questionnaire where executives cherry-pick answers to produce the outcome they want. Not a readiness survey designed by the vendor selling you the product. A diagnostic framework built on observable signals inside your tenant. This is not subjective. This is not aspirational. This is measurement. The AI Readiness Scorecard assesses 5 dimensions. Each dimension is scored from 0 to 100. The overall readiness score is a weighted average across all 5. The result is a number that tells you where you actually are, not where you wish you were. The first dimension is data governance maturity. This dimension measures whether data classification and protection are embedded in operations. Sensitivity label coverage is the primary signal. What percentage of critical data carries appropriate sensitivity labels? 0 to 20% labeling is aspirational. You have a policy nobody follows. 20 to 50% labeling is emerging but inconsistent. The organization understands classification matters but has not made it operational. 50 to 70% labeling is becoming standard. Governance is translating into practice. 70% and above, labeling is embedded. Data classification is part of how work gets done. Score this dimension based on label coverage weighted against DLP policy enforcement. Are your DLP policies actually blocking sensitive data from unintended destinations, or are they running in audit mode, triggering alerts that people ignore? Retention policy adoption factors in. Do you have lifecycle management for the data you collect? Are all documents being retired, or does everything accumulate indefinitely? The second dimension is collaboration patterns. This measures how knowledge flows through your organization. External sharing controls show whether access has become normalized to external parties. Low external sharing is 0 to 10% of at-risk files. Moderate external sharing is 10 to 20%. High external sharing is above 20%. Teams channel governance matters. Do you know who owns each channel? Are channels being retired when projects end, or does the channel count grow indefinitely? Anonymous sharing link usage reveals default sharing behavior. If links are the primary sharing mechanism, access control has been deprioritized. Co-authoring activity levels show whether knowledge work is happening in modern platforms or scattered across email. When a team's co-authoring activity is high, knowledge is being created collaboratively in shared documents. When co-authoring is low, documents are being versioned through email and stored individually. The third dimension is security posture. This measures whether access controls align with organizational need. Permission reviews frequency determines whether entitlements are actively maintained or accumulated passively. Annual reviews are minimally adequate. Quarterly reviews indicate active governance. Monthly reviews indicate access control is a continuous discipline. Guest access governance shows whether external users are managed or simply added. Conditional access enforcement determines whether the organization is implementing least privilege access or granting broad permissions. Identity risk management examines whether the organization detects and responds to anomalous access patterns. The fourth dimension is knowledge architecture. Document metadata quality determines whether AI can understand what documents contain. When metadata is sparse, Copilot operates on file names and content alone. When metadata is rich, describing purpose, classification, department, retention period, AI can understand context and relationships. Search discoverability measures whether employees can actually find information. If searching for a budget template requires navigating 7 folder levels, discoverability is poor. Information structure consistency shows whether naming conventions are enforced and followed. Knowledge reuse patterns measure whether documents are being referenced and built upon or created independently and duplicated. The fifth dimension is organizational readiness. Change management capacity shows whether the organization has absorbed multiple transformations and has capacity for another. Governance team structure reveals whether you have dedicated leadership for AI governance or whether it is an add-on responsibility. Executive alignment on AI strategy determines whether leadership has consensus on what AI enables and what governance constraints are necessary. Workforce training plans show whether the organization is preparing employees for AI-augmented work. Each dimension is scored 0 to 100. Overall readiness is calculated as a weighted average. Data governance maturity receives 40% weight because it is foundational. Collaboration patterns receives 20%. Security posture receives 20%. Knowledge architecture receives 10%. Organizational readiness receives 10%. Most organizations, when they complete this assessment honestly, score between 40 and 60. Most organizations, when asked where they believe they are, claim 75 to 80. That gap between perception and reality is where deployment risk lives. The 90-day remediation plan, from assessment to readiness. The readiness scorecard tells you where you are. It does not tell you how to get to where you need to be. The gap between current state and readiness is closed through systematic remediation. This is not a 6-month transformation. It is not a multi-year program. It is 90 days of concentrated effort focused on the 3 things that actually matter: governance infrastructure, information architecture, and organizational alignment. Most organizations skip this. They score themselves, decide they are close enough, and deploy Copilot anyway. They are wrong. The 90-day remediation plan is not optional. It is the difference between successful deployment and another expensive pilot that gets shelved. Month 1 is assessment and foundation. The goal is complete visibility into your current state and immediate action on the highest risk exposures. You start with automated tenant assessment. Do not rely on manual audits conducted by consultants asking executives what they think is true. Use readiness APIs and governance dashboards that extract facts from your tenant. The assessment examines licensing configuration, Entra ID setup, Defender enablement, purview policies, and collaboration patterns. You are establishing a baseline. You are measuring across all 5 diagnostic signals. How much data is labeled? What sharing patterns exist? What permission complexity have you accumulated? What does the graph actually look like? Simultaneously, you identify oversharing risks. This is not theoretical. You use Purview to scan for files marked confidential that are accessible to thousands of employees. You identify external sharing that exceeds organizational policy. You flag files with public access that should be internal. This scans your entire tenant. It finds the egregious exposure. The goal is not to fix everything in month 1. The goal is to know where the highest risk exposure lives and address it immediately. You establish sensitivity labeling standards, not aspirational standards that executives wish people would follow, practical standards that reflect how work actually gets done. You identify 5 to 10 critical data categories: financial data, customer data, employee data, intellectual property, strategic plans. You define what those labels mean operationally, what data gets each label, who can create labeled documents, what happens when someone tries to share a labeled document externally. You do not need perfect classification. You need governance that protects critical assets. You apply labels to existing repositories where critical data lives. Not everything. Your critical assets, the documents that would actually matter if they were exposed. Month 2 is governance, enforcement, and architecture. You implement DLP policies for the data categories you identified. DLP does not prevent all file sharing. DLP blocks specific file types or content patterns from reaching specific destinations. An email containing a credit card number gets blocked. A document marked as proprietary gets blocked from external email. A file containing a customer name and social security number gets blocked from Teams channels. The policies are narrow and specific. They enforce consequences for the most critical exposure pathways. You enforce information architecture standards. If you have naming conventions, they become non-optional. Channels are created through a process, not ad hoc. SharePoint sites use standardized permission structures. You establish a governance council. This is cross-functional. It includes IT, security, compliance, data governance, business transformation, and HR. The council meets weekly. It reviews governance gaps. It approves exceptions. It ensures that no single department's requirements force exemptions that compromise the entire enterprise. The council becomes the decision-making body for what gets governed, how strictly, and who has authority to make exceptions. Month 3 is pilot and measurement. You deploy Copilot to a pilot group, not the entire organization. A division or department where you can monitor usage carefully. You have applied sensitivity labels. You have implemented DLP policies. You have governance council oversight. The pilot group uses Copilot and generates data on actual usage patterns. What files does Copilot retrieve? What queries are users asking? Where are the failures? Where is the friction? You monitor. You measure productivity impact. You do not declare success based on enthusiasm. You measure time spent on tasks, document creation speed, analysis completion. Did Copilot actually increase productivity, or is it a novelty tool that people use because it is new? The critical requirement is this: governance is continuous, not a one-time implementation. After 90 days, you do not declare victory and move on. You conduct monthly readiness reviews. You update policies quarterly. You refine information architecture continuously. Governance is operational discipline, not a project with a finish line. Organizations that complete this 90-day plan report 40 to 60% faster time to value for Copilot. They deploy enterprise-wide with confidence because they have fixed the foundational problems. They encounter fewer stalls and fewer security incidents because governance is functioning before the organization relies on it. This is not an optional step. This is the price of admission to successful AI adoption. The AI Center of Excellence Blueprint, organizational structure. Most organizations lack the cross-functional governance structure required for AI maturity. They have an IT department. They have a security team. They have compliance. But they do not have a unified body responsible for translating AI strategy into operational discipline. That gap is the difference between remediation plans that work and remediation plans that stall at month 2. The AI Center of Excellence is not a department. It is a governance structure, a permanent body responsible for sustaining the shift from reactive governance to architectural governance. It exists because AI deployment is not a one-time project. It is a continuous operational reality. Someone has to own that reality. The AI KOE must be cross-functional. It includes CIO or CTO leadership, someone with authority over technology strategy, data platforms, MLOps discipline, and cloud architecture alignment. This person ensures that AI capabilities are built on infrastructure that can sustain them at scale. They prevent departments from selecting AI tools that cannot integrate with enterprise systems. They enforce standards for how models are deployed, versioned, and retired. The COE includes security and compliance leadership. This person manages risk assessment, policy enforcement, audit readiness, and regulatory alignment. They do not prevent AI deployment. They ensure that deployment occurs within risk boundaries. They work with the CIO to understand what governance controls are necessary and which are excessive. They translate regulatory requirements into operational policy. The COE includes data governance leadership. This person owns data quality, sensitivity classification, retention policies, and knowledge architecture. They maintain the standards established during the 90-day remediation. They expand labeling programs beyond the initial critical data to cover the broader knowledge landscape. They oversee retention policies. They ensure that old data is retired, not accumulated indefinitely. The COE includes business transformation leadership. This person defines use cases, measures ROI, manages change management, and ensures adoption. They prevent AI from becoming a technology deployment with zero organizational benefit. They work with business units to identify where AI can actually improve productivity. They measure whether Copilot actually saved time or simply created new ways to work. They manage the organizational change required to shift from established workflows to AI-augmented work. The COE includes HR and workforce enablement leadership. This person designs training programs, manages skills development, and addresses cultural resistance. They acknowledge that AI creates fear. They design training that acknowledges that fear and shows employees how to work effectively with AI. They track whether upskilling is actually happening or whether training is being completed and forgotten. These 5 roles cannot report to different leaders. That is the structure most organizations default to, and it fails. The CIO reports to the CTO, security reports to the Chief Security Officer, compliance reports to the Chief Compliance Officer, data governance reports to the Chief Data Officer, business transformation reports to the Chief Operating Officer. They have no unified authority. Their incentives diverge. Each operates within their domain uncoordinated. The AI COE requires unified governance. A single executive, likely the CIO or a chief AI officer, with direct authority over all 5 roles. This person has organizational standing to make decisions that cross functional boundaries. They can require compliances policies to be implemented through IT. They can demand that business units adopt governance practices that slow deployment if necessary. They can trade off conflicting priorities. They can make the trade-offs stick. The governance cadence is critical. Weekly operational meetings address immediate issues: a Copilot deployment stall, a DLP policy that is blocking legitimate work, a new AI agent that requires security review. Monthly steering committee reviews examine broader patterns. Are we making progress? Are policies working? Do we need to adjust? Quarterly executive briefings align the organization's leadership on AI strategy and governance maturity. The COE Charter must explicitly address AI agent oversight, data access governance, responsible AI practices, and cost management. The Charter is not aspirational. It is operational. It specifies decision authority. It specifies escalation paths. It specifies review frequency. It makes clear what the COE owns and what it does not. The cost structure is straightforward. A functional AI COE typically requires 8 to 12 full-time employees. That is budget. It is not optional if you want governance to function. The ROI emerges within 12 to 18 months through accelerated deployment, risk mitigation, and avoided breach costs. The COE exists because governance is not something IT does to the business. Governance is the structure that enables the business to adopt AI safely. The COE is that structure. The governance evolution, from restrictive to attainable. Traditional governance operates as a binary system: approve or deny. A request comes in, a committee reviews it, the committee votes, the decision is made, the process takes weeks. By then, the business need has moved on. The market has shifted. The competitive advantage is gone. This governance model was designed for a world where technology changed slowly and decisions had long operational lifespans. It does not work for AI at scale. Restrictive governance stifles innovation. Organizations become unable to move fast enough to compete. A team identifies an opportunity to use Copilot in a workflow. They request approval. The governance committee convenes in 3 weeks. They review the use case. They ask questions. They require risk assessment. They demand compliance review. 2 months have passed. The competitive window has closed. The organization decided AI is too slow to deploy. What actually happened is governance was too slow to enable deployment. This is the trap that has caught most large enterprises. They built governance frameworks designed to prevent risk through gatekeeping. The frameworks work, risk is prevented, and innovation is prevented equally effectively. The organizations become safe but stagnant. Attainable governance operates on a different principle. Instead of asking what we can prevent, the question becomes, how do we enable safely? Instead of approval gates that block deployment, attainable governance embeds controls into the workflows themselves. The controls still exist. They are simply invisible to the user. The friction disappears, the speed returns, the safety remains. The implementation patterns are straightforward. Role-based access for Copilot means that users in different roles have different access to AI capabilities. A frontline worker uses Copilot for task assistance. A manager uses Copilot for analysis and reporting. An executive uses Copilot for strategy. Each role has access to the data their role requires. The system enforces the restriction automatically without asking permission. Data residency enforcement happens at the infrastructure level. Customer data stays in the region where the customer operates. The organization does not require a policy exception process for every data access. The system enforces it structurally. DLP at the point of retrieval does not require approval workflows. A user attempts to ask Copilot a question that would retrieve personally identifiable information. The system blocks the request silently and explains why. The user modifies their question. The system allows it. No governance committee was convened. No approval was required. The control was embedded in the system. The user experienced friction but not delay. Audit trails for accountability exist invisibly. Every interaction is logged. Every access is traceable. If a breach occurs, the organization can answer what happened, who did it, and why. No manual audit process is required. The system maintains the records automatically. The governance paradox is this. More controls can enable faster deployment if controls are invisible to end users. Sensitivity labels enforce data governance automatically. A document is labeled confidential. When someone attempts to share it externally, the system blocks the share. The user does not need approval. The system enforces the policy. Users experience no friction because labeling happened at document creation, not at enforcement time. Conditional access policies enforce security posture without requiring user intervention. A user attempts to access Copilot from a location the organization has deemed risky. The system requires additional authentication. The user provides a second factor. Access is granted. The security posture is enforced. The user experienced a 30-second delay, not a 3-week approval process. DLP policies block sensitive data from Copilot retrieval without disrupting legitimate knowledge work. A financial analyst asks Copilot to summarize quarterly earnings. The system retrieves the relevant documents. The analyst gets their answer. The system silently confirms that no PII was included in the response. The control was enforced. The user was unaware the control existed. The cost of attainable governance is higher upfront design effort. You cannot implement role-based access without understanding what data each role legitimately needs. You cannot enforce data residency without building the infrastructure to support it. You cannot embed DLP without mapping sensitive data categories and understanding where they exist. This work is not trivial, it is architectural. But the operational friction is dramatically lower. Once embedded, these controls require minimal ongoing maintenance. They scale automatically. They do not require approval committees. They do not slow deployment. They enable deployment because organizations gain confidence that AI is operating within acceptable risk bounds. This is the transition from governance as an inhibitor to governance as an enabler. When governance is attainable, organizations move faster, not slower. They take larger risks, not smaller risks. They scale AI adoption because they trust that safety is built into the system. Governance infrastructure that achieves this foundation enables the next critical pillar, talent and skills. Because safety enables opportunity, and opportunity drives the urgency of building organizational capability. Talent and workforce transformation, from prompt engineering to architectural literacy. Organizations often make a foundational mistake in workforce preparation. They hire AI specialists to implement Copilot. They send employees to prompt engineering boot camps. They treat AI capability as a specialization that belongs to a small dedicated team. This is a fundamental misunderstanding of what organizational AI maturity actually requires. Prompt engineering is a tactical skill. It has a useful lifespan of 12 to 18 months. You learn how to structure prompts. You understand how language models respond to different framing. You become efficient at extracting useful outputs. And then the models change. A new version releases. The prompt techniques that worked become ineffective. You relearn. You optimize for the new model. You build new habits. This cycle repeats continuously. Prompt engineering is perpetual translation work. It is valuable for operational efficiency. It is not strategic. It does not compound. It does not create organizational advantage that persists. Architectural literacy is something else entirely. It is understanding how information flows through your organization. It is understanding how data governance constraints enable rather than inhibit AI. It is understanding how organizational silos prevent knowledge synthesis. It is understanding that AI is not a tool that organizations adopt. AI is a reflection of how organizations operate. If your organization has fragmented knowledge, AI will expose that fragmentation. If your governance is suffocating, AI will reveal that suffocation. If your teams do not communicate, AI will amplify that dysfunction. Architectural literacy means understanding these relationships deeply enough to restructure how work gets done. The skills gap is significant. 80% of the workforce needs retraining to work effectively with AI. That is not prompt engineering training. That is fundamental rethinking of how work gets done in an AI-augmented environment. Most organizations have no training plan. They have no strategy for workforce transformation. They have hope. They assume people will figure it out. And when Copilot is deployed, they discover that people have not figured it out. Adoption is slower than expected. Productivity gains are smaller. Users treat Copilot as a novelty rather than a transformation. What organizations actually need is different from what they are hiring. They do not need prompt engineering specialists. They need data architects who can redesign information architecture to support AI. They need governance specialists who can translate policy into operational discipline. They need change management leaders who understand that AI adoption is cultural transformation, not technology deployment. They need business process designers who can restructure workflows around AI-augmented work. These roles are rare, they are expensive, and they are essential. The workforce transformation requirement is this. Upskill 50% of employees on AI concepts, governance, and responsible use. Not everyone needs deep technical capability. Not everyone needs to understand model architecture. Everyone needs to understand what AI can and cannot do. Everyone needs to understand how to work safely with AI. Everyone needs to understand how their role changes in an AI-augmented environment. The training framework operates at 3 levels. Foundation level is AI literacy for everyone. What is artificial intelligence? How does machine learning work? What are the limitations of large language models? What are the risks of AI? This is conceptual. This is philosophical. This teaches people why AI matters and why governance matters. Intermediate level is AI-specific roles. Data analysts learn how to structure queries for AI. Content creators learn how to prompt effectively. Managers learn how to evaluate AI outputs and assign accountability. This is tactical. This is skill building. Advanced level is AI, governance, and architecture. This teaches people how to think about information architecture, how to design governance structures, how to manage organizational transformation. The cultural shift is profound. The dominant organizational narrative around AI is fear. AI will replace me. AI will make my job obsolete. This narrative is not entirely unfounded. AI will replace some jobs. It will transform most jobs. But the organization that reframes this narrative gains enormous advantage. The narrative should be this: AI will amplify my impact if I learn to work with it. Your job is not going away. Your job is changing. The work that is repetitive and mechanical will be automated. The work that requires judgment, creativity, and human connection will become more valuable. If you upskill now, you will be doing higher value work in 12 months. If you do not upskill, your role will become less relevant. Change management is not optional. It is the primary determinant of whether AI deployment succeeds. Organizations that invest in workforce transformation report 25 to 40% productivity gains. Organizations that do not invest report flat or negative ROI. The difference is not the technology. The difference is whether people have been prepared to work effectively with it. Culture and organizational readiness, the silent determinant of success. Technical readiness is necessary. It is not sufficient. An organization can have immaculate data governance, perfect information architecture, and enterprise-grade security posture. An AI deployment will still fail if the organization's culture is not ready. Culture is the silent determinant of success. It is invisible in readiness assessments. It does not appear in audits. And it is the difference between AI becoming transformational and AI becoming expensive theater. The dominant cultural barrier is fear. Employees do not understand how AI works. They do not know whether the organization will use it against them. They do not know whether their job is at risk. They do not know whether their work is being surveilled. This uncertainty creates resistance, not outright rebellion. Quiet, persistent resistance. People do not adopt Copilot because they are waiting to see whether it is safe. They do not contribute to collaborative platforms because they do not trust where their contributions will be seen. They do not share knowledge because they are uncertain whether sharing knowledge makes them replaceable. The fear is not irrational. AI is genuinely capable of replacing some jobs. AI will make some skills less valuable. Some people will become less relevant to their organizations if they do not adapt. The fear is accurate. The question is whether the organization addresses the fear through transparency or allows it to fester into dysfunction. Trust is the prerequisite for adoption. Organizations with high-trust cultures adopt AI 3 times faster than low-trust cultures. The difference is not the technology. The difference is whether employees believe the organization has their interests in mind, whether the organization communicates honestly about what AI is and what it will do, whether the organization invests in people despite technology that might reduce the need for some roles. This trust does not appear on a readiness scorecard, but it determines whether Copilot succeeds or becomes an expensive tool that nobody uses. Transparency is the enabler. Organizations that openly communicate about AI governance, audit practices, and data usage gain employee buy-in. They explain how Copilot works. They explain what data it can access. They explain how usage is monitored. They explain that monitoring is not surveillance for the purpose of finding people to fire. It is operational discipline to ensure the system is working as intended. This transparency does not eliminate fear. It channels fear into legitimate concern rather than paranoia. The change management imperative is clear. Every AI deployment requires explicit communication about why it is being implemented. What problem does it solve? How will it affect roles? Who will do what work differently? Who will move into new responsibilities? The organization that deploys AI without answering these questions will encounter resistance. The organization that answers them gains alignment. Executive alignment is critical. If the CEO says AI is transformational while the CFO sends memos about cost reduction, the mixed message creates confusion. If the COO emphasizes that AI will improve efficiency while the head of people operations suggests that some roles might be consolidated, employees hear threat. They protect their interests. They slow adoption. They become the drag on deployment. The executive team must speak with a unified voice about what AI enables, what changes it requires, and how the organization will support people through those changes. The governance narrative matters more than the governance itself. If governance is framed as restriction, employees see it as the organization controlling them. If governance is framed as enablement, employees see it as the organization protecting them. The narrative is this: we are governing AI so you can use it safely. We are ensuring that AI does not expose your personal information. We are making sure AI does not violate regulations that protect customers. We are building governance so you can trust the AI you are working with. That narrative creates buy-in. The alternative narrative, we are monitoring AI to prevent misuse, creates resistance. Organizational design matters. Governance that is centralized in IT fails. Governance that is distributed, where every business unit owns AI readiness, succeeds. When IT owns governance, business units resent it as overhead. When every unit owns governance, governance becomes part of how work gets done. The organizational design that works is empowerment with guardrails. Business units have authority to adopt AI. The AI Center of Excellence provides the guardrails that prevent them from adopting irresponsibly. The cultural signal is observable. Organizations with high adoption of collaborative tools, with active knowledge sharing, with cross-functional teamwork already embedded in how work gets done, adopt AI 2 times faster than organizations where silos dominate. The organization where engineers talk to product managers, where product managers listen to support teams, where executives read reports from frontline workers. Those organizations adopt AI faster because they already have the cultural infrastructure that AI requires. They already practice transparency. They already communicate across boundaries. They already trust each other enough to share work. These organizations are not common. Most organizations have silos. Most organizations have limited transparency. Most organizations have low trust. Building readiness is not about technical infrastructure. It is about building culture, and culture change is the work that matters most. The maturity inflection. When readiness becomes competitive advantage. Organizations at stage 3, maturity, experience exponential returns. Governance becomes invisible, embedded in workflows, not enforced through approval gates. At this stage, Copilot delivers measurable value, 25 to 40% productivity gains, faster decisions, improved compliance. Organizations below stage 3 spend 60% of AI effort on remediation. Stage 3 inverts this: 40% governance, 60% innovation. By 2027, stage 3 organizations gain 2 to 3 year competitive advantage overall. Agentic AI, autonomous agents executing complex tasks, remains viable only for mature organizations. Deploying agents without stage 3 governance creates uncontrollable risk. The cost of waiting compounds quarterly. The uncomfortable truth: why most organizations will fail. Organizations will read this episode and believe it describes other companies, not themselves. This is the most persistent cognitive bias in enterprise technology adoption. The bias operates at every level of the organization simultaneously. Executives believe their organization is different, their culture is unique, their data is already governed, their teams communicate differently. They are the exception. They are not like the manufacturing company with SharePoint sprawl. They are not like the financial services organization with over-restricted data. They are not like the scale-up with open sharing culture. They are special. This belief is universal. It is also almost always wrong. Leadership overestimates their organization's maturity by 1 to 2 stages on average. An organization operating at stage 2 maturity believes it is at stage 3. An organization at stage 1 believes it is stage 2. The overestimate is systematic. It is not malice. It is not ignorance. It is cognitive bias. Leaders operate in the upper levels of the organization where decision-making happens. They do not see the fragmentation that exists at scale. They do not see the sprawl. They do not see the siloed knowledge. They see their own disciplined decision-making and extrapolate that to the entire enterprise. It does not work that way. Discipline at the executive level does not guarantee discipline at scale. The "we are different" fallacy operates in every conversation. A manufacturing company executive says, "We are unique because we have structured ERP systems." A financial services executive says, "We are unique because we have compliance infrastructure." A healthcare organization says, "We are unique because we have massive data volumes." A scale-up says, "We are unique because we have digital native culture." A government agency says, "We are unique because we have legacy constraints." Each organization is correct that it is unique. None of that uniqueness exempts them from the patterns described in this episode. The patterns repeat across industries, geographies, and company sizes with striking consistency. The specific form varies. The underlying failure mode is identical. The primary failure point is this: organizations implement stage 3 governance while operating at stage 2 maturity. They deploy policies that do not match organizational readiness. Sensitivity labeling policies exist, but adoption is below 20%. Retention policies are documented but not enforced. DLP rules are configured, but people do not understand what they do. They declare governance as complete while the underlying maturity remains immature. This mismatch creates governance theater. Policies exist on paper, controls exist in configuration, compliance exists as documentation. Reality is something else entirely. SharePoint sites are still overshared. Teams channels still sprawl. Knowledge still lives in email. The policies are bypassed daily through workarounds that nobody tracks. This mismatch creates a deceptive state. The organization can truthfully say it has implemented governance. Auditors find policies in place. Compliance reviews show configuration that aligns with stated standards. But operational reality contradicts documented reality. The gap is where risk lives. The gap is where breaches happen. The gap is where AI deployment stalls. The cost of failure is quantifiable. Organizations that deploy AI without achieving stage 3 maturity experience stalled deployments. Weeks 6 through 12 are where most deployments halt. They experience security incidents. Oversharing that was invisible under human-scale access becomes amplified when AI can traverse it in milliseconds. They experience regulatory scrutiny. Governance frameworks that looked adequate on paper prove inadequate under inspection. They experience wasted licensing spend. Copilot licenses that cost $30 per user per month are purchased and unused. The total cost of failure ranges from $2 to $3 million for a mid-market organization to $10 to $20 million for enterprise scale. The path to failure is well paved. Organizations follow it with consistency, buy Copilot licenses because the board demands AI adoption. Deploy to pilot users without addressing governance prerequisites. Encounter governance gaps at weeks 6 through 12. Stall the deployment while trying to retrofit governance. Declare that AI is not ready for the organization. Shelve the investment. Repeat with another AI tool in 18 months. What separates organizations that succeed from organizations that fail is not luck. It is not the quality of the technology. It is not executive vision. It is this choice. Do you invest in maturity before deployment, or do you discover immaturity through failure? The organizations that succeed are those that accept one uncomfortable truth early. You are probably not ready. That admission is the starting point for change. You are probably not ready is not a statement of inadequacy. It is a statement of fact. You are not designed for AI-augmented work. Your information architecture was not built for machine-scale retrieval. Your governance was not designed for autonomous systems making decisions on behalf of humans. Your workforce was not trained to work with AI. Your culture did not prepare for the speed of change that AI introduces. None of this is your fault. You were operating in a world where AI was theoretical. Now it is operational. The gap is expected. The question is what you do about it. The organizations that fail are those that deny the gap. They believe they are ready. They believe their situation is different. They believe their governance is sufficient. They deploy anyway. And they discover the gap through incident, regulatory scrutiny, or pilot failure. By then, the cost is higher. The organizational patience is lower. The recovery is slower. They could have invested in readiness proactively. Instead, they invested in remediation reactively. The outcome is the same. They arrive at readiness. The path was just more expensive. So the path forward, from trap to transformation. AI readiness is not about buying Copilot. It is about whether your organization's knowledge, governance, and collaboration patterns are mature enough for AI to work safely and effectively. The 5 pillars are interconnected. Weakness in any one pillar creates cascading failures. The diagnostic signals, collaboration patterns, governance behavior, knowledge architecture, security posture, graph health, reveal true maturity beneath organizational assertion. The 90-day remediation plan is achievable. Organizations that commit report measurable progress within 3 months. The AI Center of Excellence provides the structure required for sustained maturity. The governance evolution from restrictive to attainable enables faster deployment without sacrificing control. Workforce transformation is not optional. It is the primary determinant of whether AI creates value or cost. The uncomfortable truth: most organizations are not ready. The cost of discovering this through failure is substantial. But the opportunity is clear. Organizations that achieve stage 3 maturity will gain 2 to 3 year competitive advantage. Agentic AI, autonomous systems executing complex workflows, becomes viable only at stage 3 and above. The organizations that deploy agents without maturity create uncontrollable risk. The organizations that achieve maturity unlock capability that their competitors cannot replicate for years. The next step is honest assessment. Use the readiness scorecard. Measure where you actually are, not where you wish you were. If your score is below 65, begin the 90-day remediation plan immediately. If your score is above 75, focus on continuous governance rather than foundational remediation. Either way, accept that AI readiness is not a destination. It is a continuous operational discipline. Connect with me on LinkedIn, Mirko Peters, to discuss your organization's AI maturity journey or to suggest the next uncomfortable truth we should examine.